Hi, Ms. Bricker. These are my rules for derivatives that I've learned over the course of this year. We first got the constant rule. When you have any constant and you take the derivative of it, it will become 0. We got the power rule, the good old power rule that you use for most of the derivatives. Simply, you take the power that it is in originally, you subtract 1, and then you bring that number that you had down, and that'll allow you to take the derivative quickly. And you use this in combination, usually with the constant rule, in order to get your simple derivatives. But when your derivative needs multiplying and is being multiplied together, you need to use the product rule, where you take f prime times regular g, and then you take g prime times f, and then you add those together, and then that'll give you it when your position is being multiplied together. Same thing with quotient rule. That'll help for when your initial one's being divided by. You take f prime times g prime times f, you subtract those, and you put it over g squared. And then chain rule is when you have like multiple different parts of the thing that need to be derived, and so you take the whole entire thing and you derive it, and then you take the middle of the function to derive it, and that'll give you something, or your derivative for the overall parentheses ones. And then you got all your sine, cosine, tangent ones down here, and then these rules can be applied to position, velocity, and acceleration going upwards. So you can take the derivative of the position, get the velocity, take the derivative of the velocity, get the acceleration. So my first problem is this problem, and we will be using the constant rule and the power rule to find this equation. So h of prime of x will equal, power rule will be 16x cubed minus power rule 6x squared plus 8x plus 16, and then since this is a constant, it's plus 0. You don't really need that. So then this will be that will be your answer. And those are using the power rule and the constant rule. This one will be using the product rule. And I'll also be using some of the cosine and tangent rules that we need in order to figure it out. So cosine tangent, cosine sine. So it'll be f prime times g plus g prime times f in order to find f prime. So we'll plug our f prime to this, and then our g prime, or our g is this. So our f prime of that, f prime of x, will be equal to f prime of that, so it'll be 2x times our g, which is just cosine 2x. And then that's 1, and then you add that to g prime, which is going to be, will be negative sine 2x times f, which is just x squared. And you add those together. So you just do 2x. You can just leave it as this, times cosine 2x minus sine 2x times x squared. That's your answer. And then this one, you're going to use chain rule and your constant rule technically, and power. So initially you take the chain rule of this, so you'll get for s prime of x, you'll get 2, then you have the parentheses x squared plus 5x plus 4, and then so it'll be 2 minus 1, or equals just 1. So you'll have nothing there. So it'll be s prime x equals 2 x squared plus 5x plus 4 times 1 times your s prime of the middle part of that equation right here. So you're gonna take the derivative of this and then multiply it to the back of it to find your whole entire equation. So it'll be like this, equals to x squared plus 5x plus 4 times, and then you take the derivative of that, will be 2x plus 5 plus 0 for your constant. And you simplify these together, so it'll be s prime equals, distribute this. This will be 2x squared plus 10x plus 8. And you multiply this times 2x plus 5. If you can go one more time, it'll be 4x cubed times that plus 20 x squared plus 16x. You do the 5, so then you get 10x squared. You get 50x, and you get 40. So then your final equation will be 4x cubed plus, you got these two, so it'll be 30x squared plus these two, which will be 66x plus 40. That'll be your final answer right there. It's a little bit of a tricky long one. Our next problem will be a optimization problem where you're trying to find the most efficient way to make the largest area using 3 sides of a fence and a barn side. My dad wants to re-fence my grandpa's ranch for him. My dad went to Home Depot and purchased 20,000 feet of steel fencing. The barn will serve as one side of the yard. What is the maximum area of the fence? So what is the maximum area is what you're trying to achieve possible with the 20,000 yards as your perimeter. Although you're only using 3 sides, so you're going to have the length right here, and then the width of how far it is. So you got 20,000 for that, and then you subtract that. So you subtract the 2w to find an L. And then from the L, you can plug that into the area problem, because you got L times W. And from that you can solve, and you can put the 20,000 in, and then you can solve down for the perimeter, and you can find out that L is 10,000. So once you find out that L is 10,000, you can go over here, plug it in, find the width, and you get 5,000, and then you plug it in to the area, and then you get your maximum square feet. And then this is a velocity problem. You use this equation to find, this is your initial equation, which gives you the particle position if you plug in a number for how many seconds has passed. And it's asking for what is the particle velocity at t equals 2 and the acceleration at t equals 3. So in order to find the velocity at t equals 2, you need to take the derivative of this equation. So I got the derivative of 3t squared minus 6t minus 9 with the constant rules and all the rules that I've learned. And then you plug in the 2 from up here, the t equals 2, to find the velocity at 2. So you plug it in, and you get 4x squared, whoops, I plugged in a 4. So then you get, this will be 12, and then this will be 12 minus 9, so then you'll actually get negative 9. So this didn't plan out as well, but that gets negative 9. And then over here, keep plugging that in, keep plugging that in. So you work down, and you plug in t equals 3 at 3, because it wants to know acceleration at 3. And you eventually work down after taking the second derivative again, because that's how you get acceleration. You get down to 12. So the acceleration at t equals 3 is 12. And lastly, we have a curve sketching problem. So this is the initial equation that you want to try to curve sketch. And from this, you can figure out the horizontal asymptote just by the pre-calculus skills that we have, and you figure out that it's 1 over 1 because it's the same power. And then from this, the derivative, which allows us to curve sketch, gives us info on increasing and decreasing, so we can figure out if the graph's going up or down. And this will determine, when we take the second derivative test, we can figure out if it's concave up or concave down. And from g prime, we solve, and we have to use the quotient rule because it is being divided by, so we eventually work it out to here. And then we use the quotient rule again to find the second derivative, which works it out to here. And then we take the test by plugging in 0 and 3 into these equations. To take the first derivative test, we plug it into this one, plug 0 and 3 into that, and then we figure out that it's negative and negative. So, and then the second derivative test, we plug 0 and 3 into this equation, and we figure out it's negative and positive, and we find our POI. And from that, we can go to the graph, and we can realize that there will be an asymptote at 2, because of the 2, and then we could find out there's an asymptote at 1 because of the 1, and then from that we can find the concavity and the increasing and decreasing based on it, so we can realize that it'll be going this way and going that way with an asymptote here and here. And that is it for derivatives.